Hello, everyone. This course, we will introduce some basic of BGP function. As we know, BGP also is a dynamic routing protocol, but usually if you have multiple AS between different organizations, we can use the BGP protocol to transfer the routing information. And finally, all the network devices can get the routing and help us to forward the message. And if you have the BGP protocol in your network, one problem is the routing black hole. And what means a routing black hole? That means, like the lab guide show you, if a router receives a data packet, but we cannot forward the message because we don't have the routing information. So how to solve this problem? How to avoid the routing black hole? And in this lab, we will show you an example. And about this lab, the first purpose is you must know how to give the BGP configuration, and then you can get the routing information. Then in some special topology, if you deploy the wrong configuration, maybe there is a problem for the routing black hole. So if you have this problem, how to master the solution to solve the problem? So this is our two purpose. And here is the example topology. We have 5 routers, route 1, 2, 3, 4, 5. And about the route 1, route 2, route 3 belong to the AS 200. And the route 4 belong to AS 100. Route 5 belong to the AS 300. Maybe one AS belong to one organization. So between different AS, like AS 100 and AS 200, we use the BGP and they deploy the eBGP pair. And also the same relationship between the R5 and R3, AS300 and AS200. And in the AS200, we have 3 routers, route 1, route 2, and route 3. And route 1 and route 3, we will use the BGP. In between them, we deploy the iBGP pair. But like the topology, we only have the iBGP pair relationship, but we don't have the physical link. And about the R2, we only have the IGP protocol, but we don't run the BGP protocol. So this is the basic information. And we also have the loopback 0 address to make them to become the router ID. And the address like the 1.1.1.1 for R1 and the 1.1.1.2 for R2, something like this. And about the BGP relationship, R1 and R3 will establish the iBGP neighbor relationship, but we don't have the physical link, right? And R1 and R4 will establish the eBGP relationship. So do R3 and R5. And we will use the loopback 1 interface to simulate our service network. And R4 and R3, we will have 2 loopback 1 interface to simulate our service network. And one is the segment 4.0.1.1 and another one is 5.0.1.1. And the administrator will review BGP route entries for R5 and 4. And finally, we hope the result is the service network can ping each other successfully. So this is our requirement. And in the AS200, we also run the IGP protocol OSPF to make sure the loopback 0 interface can ping each other successful. Then we can establish the relationship about the iBGP pair. And if you want to meet the requirement, there's some configuration plan. First is basic, you have to give the correct IP address for each router. Also includes the physical interface and the loopback interface. And another one is within the AS200, we run the IGP protocol or SPF. So we have to network all the segments. Finally, we can establish the IBGP relationship successfully. Then between the different AS, we will establish the eBGP pair. But we hope we can use a loopback address to establish the eBGP pair relationship. So you have to add the static route between AS100 and also AS300. Otherwise, if you use a physical link to connect with each other, you don't need to add the static routes. And the last step, you have to configure the BGP. Includes the IBGP pair and also the eBGP pair. So this is a basic configuration plan. And then let's do it step by step. First, you have to give the correct IP address, right? And in the loopback one, we have 2 physical links and also 1 loopback address. So first is you have to create loopback 0 and give the IP address is 1.1.1.1, mask is 32. Sorry, lost the IP address. And another is a physical link to connect with R2, gigabit 01, and the IP address is 10.1.1.1, and the mask is 24. And another is a physical link to connect with R4, gigabit 00, and the IP address is 172.16.1. should be 1 and 24. This is a mask. Basic for the R1. Okay, so this is a basic. And another one for the R2. Enable config T and also have 1 loopback 0, right? And the IP address is 1.1.1.2, mask is 32. And 1 physical interface to connect with R1. The IP address is 10.1.1.2, 24. And another interface to connect with R3, 02. The IP address is 10.1.2.2, 24. Okay, this is a basic for R2. And another one for the R3, we also have 3 interfaces. One is a loopback address, 1.1.1.3, 32. And another is physical link to connect with R2. And we give the 100, 10.1.2.3, mask 24. Or lost IP address. IP address. And another interface, gigabit 01 to connect with our R5. The IP address is 192.160.1.3, 24. Okay, so this is basic for R3. And another one is for R4. About R4, we have 3 interfaces. One is the loopback 0 address. Later, we will use this IP address to establish the eBGP relationship with R1. And the IP address is 1.1.1.4, 32. And another is the physical interface for the gigabit 00. This is the IP address to connect with R1, 172.16.1.4, 24. Okay, and another is the service network, loopback 1, and the IP address is 4.0.1.1, 32. Okay, and the last one for R5. R5. and the interface loopback 0. IP address is 1.1.1.5.32. And another physical interface to connect with R3, the IP address is 192.168.1.5. Okay. Mask is 24. And another service address is loopback 1. And the IP address is 5.0.0.1.132. Okay, so this is a basic configuration for the interface. Rollback R1 to R5. Okay, and later we can configure the IGP. So in the AS200, we will use the OSPF. So about the R1, you have to running the OSPF. Exist and the router OSPF 1. And the network 1.1.1.1, the mask is 0.0.0.0.0, right? And another one, you have to network the physical link to connect R2 10.1.1.0, 0.0.0.255, and also belong to area 0. Okay, so this is a basic R1. But the physical link to connect with our R4, you don't need to advertise. This link belongs to the external network. Okay. And about the R2, also router OSPF 1, and the network, your loopback address 1.1.1.1.2.0.0.0.0. And another is network 10.1.1.0, 0.0.0.255.0.0. And the one link to connect with R3, 10.1.2.0, 0.0.0.255, and also area 0. So if you advertise the link to connect with R1, you will directly to find some debug information from OSPF. Like now your status is becoming from down to initial and finally to become full, right? So this is a basic of R2. And also about the R3, router OSPF 1, you have to network your loopback address 1.1.1.3, 0.0.0, area 0. And another is network 10.1.2.0, 0.0.255, area 0. Lost 10. Okay. So now this is a basic configuration of OSPF. If you advertise successfully for OSPF, now I think you can receive all the loopback address from route 1 and route 2 and route 3 by the OSPF protocol. So you can use command show IP route to check the result. Now you already know the basic loopback address of all the routers, right? And also the physical link between R1 and R2 for the routing information. And the next step, you have to add the configuration for the BGP. So the basic is between R1, AS200 and AS100, and also the AS200 and the AS300, they have to establish the eBGP neighbor relationship. But in this topology, we try to use the loopback address to establish the relationship. So you also have to keep your TCP connection is ready. But about round 1, you can check your results. show your IP routing table, you can find you already know the loopback address of R2 and R3, but you don't have the loopback address routing information for R4 because we don't run the dynamic routing protocol, right? So you can add the static route for your eBGP neighbor relationship. So on the R1, you can exist and add the IP route 1.1.1.4. The mask is 255.255.255.255. 172.16.1.4. This is the IP address for the R4 physical interface. And then for the R4 also is same. If you show your IP route, now you only have the direct routing information, and you also don't have the neighbor address for R1, 1.1.1.1. So you can add a static route, one IP route, 1.1.1.1, 255.255.255.255, 172.16.1.1. Okay, so check your IP routing table again. Now you have the static route, and you can try to ping the TCP connection. Ping 1.1.1.1. It is working. Also same about R3 and R5. They must have the routing information for the static route. So on the R3, you have to add IP route 1.1.1.5, 255.255.255.255. Next hop is 192.160.1.5. And on the R5, the routing information should be IP route 1.1.1.3, 255.255.255.255. Next hop is 192.168.1.3. Okay, so it is working now in the R3. On R3, you can show IP route. It is working. And later, you can do the basic configuration for BGP. And about the BGP, we have two eBGP relationship, right? And also one iBGP peer. So on R4, you can add the eBGP peer relationship first. On the global configuration, router BGP in the AS number is 100. And you can do the node synchronization. And about the R4, we only have one neighbor. The neighbor is R1, 1.1.1.1, and the R1 located on the remote AS200, right? And now we use the loopback address to establish the relationship. So you have to change your neighbor 1.1.1, update source is your loopback 0. Okay, and by default, the TTL value only support 1 in the eBGP. So you have to modify the eBGP multiple hop. Neighbor 1.1.1 and the eBGP multiple is 100. You only to modify the max hop more than 3 is enough, but here we use 100. You also can use the number 10. And then you have to advertise your service network to a neighbor, right? And we will network 4.0.1.0. And the mask 1.1 should be. And the mask is 255, 255, 255, 255. And then you have to network your service segment 4.0.1.0 and the mask 255.255.255.0. Okay, we lost one keyword mask. Okay, so this is a basic one for the R4. And about the R1, you have two relationships, right? Router BGP 200, and you will have one no synchronization, one eBGP relationship with R4, and the neighbor is 1.1.1.4, and your neighbor located on the AS 100. Sorry, 1.1.1.4. And about your neighbor, you have to use the loop 0, 1.1.1.4 to establish the relationship. Update. Update source for loopback 0. And another one for your neighbor, 1.1.1.4. You have to change the eBGP max hope to become 100, or maybe to become 10. It also is work. This is a relationship with your eBGP. And another is you also have one relationship, iBGP relationship with R3. So your neighbor is 1.1.1.3. Your neighbor located remote AS 200. Okay. And also we use the loopback 0 to establish the neighbor relationship. 1.3. Update the source loopback 0. And also please change the next hope to become ourselves. Okay, so this is a basic configuration for the iBGP relationship. So if you add the basic BGP configuration on R1, now you will find your neighbor relationship already up, right? So this is a basic for R1. And also for the R3, let's check enable configuration. And about the R3, the BGP protocol also located on AS 200 and no synchronization. And you have one neighbor with R1, 1.1.1.1 and the remote AS is 200. And about your neighbor, we will establish the iBGP peer relationship and update the source to become loopback 0. Okay, and then you will find the neighbor relationship already to become up. And also please change your next hope 1.1.1.1 next hope to become self. And another relationship with R5 is eBGP peer. eBGP 1.1.1.5 and the remote is 300. And about your neighbor, neighbor 1.1.1.5, so update source should become loopback 0. And also please change your eBGP max hope to become 100. Okay, so this is a basic for the eBGP peer. And also on R5, you have to update. router BGP 300, and your neighbor is R3 1.1.1.3. They are located in the AS200 and also 1.1.13 to become update source loopback 0. And also your neighbor eBGP max hop to become 100, right? And then you will find your neighbor immediately to become up. We establish the relationship successful. And then you have to change your, you have to advertise your service network. Network 5.0.1.0, the mask is 255, 255, 250. Okay, so this is a basic for the BGP. Then you can check something for your relationship, right? Includes R1 and R4, show IP BGP neighbor. And about the R1, first you will have the relationship with 1.1.1.3, okay? Also located in the 200. Now the status is established, successful. And also another one for your BGP 1.1.1.4, this is your eBGP relationship. And some basic information. And also same, if you check on R4, you only will have show IP BGP neighbor relationship. You will find one eBGP neighbor 1.1.1.1, right? And also the local host is 1.1.1.4, and the local port number, something like this. And the port ID for your neighbor is 179. So this is the basic one. And also you can check one by one for all the routers except R2. We can establish the neighbor relationship successful. Okay, R3 and R5 stay. And another one is you can check your BGP routing information on R4, R1, R3, and R5. You can check your service network received already successful or not. For example, on R1, use the command show IP BGP, and then you have two service network, right, on R1. One is 4.0.1.0 from R4. Next hop is R4. And another service is 5.0.1.0. The next hop is 1.1.3 is R3. And the whole path is 4.4.4.4 from AS100 and 5.0.1.0 from AS300. So this is basic on the R1. Also same on the R3, you can check the result. Show IP BGP. You can have to see these two service network. And also on the R4 and R5, you also can check show IP BGP. You will find one next hop 00 because this is an advertised router. And another one 5.1.0 from the AS300 and the AS200. This is the AS path. Okay, so this is a basic one. And also on the Route 5, you can receive the service network, IP BGP. You have to see these two segments, okay? And another one on the BGP, now we use the command show IP BGP. You can check your BGP routing table. And also you can check your IP routing table on Route 5, show IP route. You can find now we have one BGP routing located on our IP routing table. Okay, and also on the Route 4, you can check the result, show IP route. You also can find this information. Okay, and the next hop on the Route 1 and the Route 3, you can check the result, show IP routing. We can have two BGP routes, right? From different next hop. One is from eBGP R4 and another is from the iBGP R3. And eBGP and iBGP is administrative distance is different. eBGP is 20 and iBGP is 200. Also the same result you can check on R3. Show IP route. You can find two BGP routes, okay? And another one, now you will find on all the 4 BGP routers, we can receive the service segment of 4.0.1.0 and also the 5.0.1.0, right? But now if you want to ping on R4, ping 5.0.1.1 and the source is 4.0.1.1. I want to ping the destination of R5. Use my loopback 1 address. Let's see the result. You cannot ping successfully, right? According to the routing information, R4 will send the route to R1. R1 will send the route to R3 because the next hop is R3. But between R1 and R3, we don't have the physical link. So we will force a message to R5, to R2, according to the next hop information. But on the R2, let's find the result. Show IP route. We only have the OSPF route information. We don't have a segment of 5.0.1.0. That means if R2 receives the information, the destination IP address is 5.0.1.1. I will take the destination IP address to match my IP routing table, but we don't have the routing information, so I will discard. So that's the result is routing black hole. Because all the BGP routers have the routing information, but finally we cannot force a message out successful. That's because about the route 2, we only run the OSPF routing information. We don't know everything about the BGP. So how to solve this information? How to solve this problem? We also have to let the route 2 get this 2 service segment. So how to get this information? One solution is about route 2, you can run BGP protocol 2, and we establish the BGP 4 interconnection. That's been as a BGP router, route 2 also will receive this route information. Another solution is between the route 1, route 2, and route 3, we already run the run the OSPF protocol. So you can let route 2 know the information by the OSPF protocol. So route 1 and route 3 must to make the BGP routing to become OSPF LSA, and then route 2 can get this information. So how to add the configuration? On route 1, you have to enter the OSPF protocol 1, and then to do the redistribution BGP, and then to give the subnet. And also about route 3, you have to enter the OSPF and redistribute the BGP subnet. And then come back to say the route 2. You will find 2 external BGP route, OSPF route on this routing information, right? That means we get the segment information by the OSPF LSA5. Okay, so the same result if you want to ping in the R4, ping again. we can ping successfully. So very important in your network, if you use a BGP protocol, please make sure to avoid the routing black hole. One solution is in this physical topology, you can let the router run BGP protocol and then establish the BGP full connection. And the second solution is like this lab, you can make the BGP to become OSPF type 5 LSA. And the router also can get this service information from BGP. But pay attention, if you have lots of BGP routing, please make sure it is possible route 2 can get this information or not. And another solution is between route 1 and route 3, you can establish one physical link. So route 1 can directly send the information to route 3, not go to the route 2. So we have 3 solutions. But in this lab, we choose a second solution. So this key point on the BGP is the first one is before deploying BGP, we have to make sure the routing between different AS and peers are reasonable. So within the AS200, we run the OSPF protocol to make sure the route 1 and route 3 loopback address can ping each other successfully. And between different AS, for example, AS100 and AS200, we establish the static route to make sure the TCP connection is ready. And the second point is if we use a BGP relationship, establish the iBGP. If we receive the survey segment from our eBGP peer, then we will advertise this information to my iBGP peer, right? For example, I received the 4.0.1.0 from R4. Route 1 will directly send this information to route 3. And we don't change the next hop address. So about R3, maybe the next hop address still become 172.16.1.4. So the next hop will unreachable. That's why we will add the commands neighbor 1.1.1.3 and the next hop self. That means if we send the information to my neighbor, I will change the next hop to my loopback address. Okay, and another one is about the BGP route advertisement principle is first is the iBGP is one BGP speaker, that means running the BGP protocol, will only advertise the route it used to its neighbor. For example, about route 4, I can advertise the 4.0.1.0 to my neighbor. I cannot advertise 5.0.1.0 to my neighbor because I don't have the routing information. And another one is a BGP speaker advertise the routes obtained from eBGP to all my iBGP neighbor to all my BGP neighbor. That means if route 1 receives the information from my eBGP neighbor R4, I will advertise to my iBGP neighbor R3. If R1 also have one eBGP neighbor, I also will advertise to my eBGP neighbor. So this is a second principle. And the third principle, a BGP speaker does not advertise route obtained from iBGP neighbor to other iBGP neighbors. That means if R1 receives the routing information from R4, I will advertise to my iBGP neighbor R3. R3, if have another iBGP relationship, maybe from R6, I will not advertise to my neighbor again in order to avoid the loop. So that's why if you have multiple routers in the same AS, we suggest to establish a full connection. And the last one, whether a BGP speaker has route obtained from iBGP to its eBGP neighbor depends on the synchronization status of iGP and BGP. To disable the synchronization and allow eBGP to obtain the routes from iBGP, you have to use the command no synchronization. That means we will check the synchronization. I can get the routing information from my IGP2 or not. Because in this practice, we already add the command no synchronization. That means we don't check the IGP and the BGP. Otherwise, we suggest to enable this function. So in this scenario, if you enable the synchronization on R3, you don't get the routing information from 4.0 1.0. And about the route on R1, we don't have the routing information from 5.0 to 1.0 because according to the IGP, we don't have this information. That's all about this practice. Thank you.